Hey, welcome everyone. So let's get started. The company update for opening.
Yeah, I'm gonna raise prices of the boxes today. We got a whole bunch of orders in at the last minute. Our price on the Blackwell GPUs is going from like 8,600 to like 10,700. So I literally have to raise the price of the box $8,000, and that's just that even lowers our profit margin. Um, so yeah. We also got an order for a Tiny Box Pro Blackwell. I don't know if they've paid yet. I'm kind of half hoping they won't pay, because then we don't have to figure out how to build that machine. Um, but yeah, no, we got a whole bunch of orders this week. And yeah, no, I mean we actually have to raise prices. Like our supplier said we could get, I think we got 24 cards at the other price. But yeah, it's just going up.
So 73,000 something.
Basically, yeah.
Expensive.
Yeah, insane. So yeah, if you want to buy right now is literally your last chance. If you want to buy a tiny box, uh, at the current prices before I go into Shopify and change it. I don't think we've actually sold all 24. I mean, I think we sold like 16. So I think there actually are like 8 more GPUs. So
Is red price also going up?
not as far as I know. We also have 2 reds in stock. I don't think DDR6 went up that much. I think GDDR6 and DDR4 share a lot. It's not like you can reuse those processes for like HBM and stuff. So I really think it's just the RAM cost. Oh, I see all these tweets about how CXMT is going to flood the market.
I thought Corsair was going to start shipping DIMMs with CXMT memory on them.
Yeah. I don't know. I gotta like look in the market and see like if we can make DIMMs. How hard is it to make a DIMM? But yeah. Yeah. That what else? Yeah, we have to have a strictly no AI policy. Like again, it's not that you can't use AI, but if it looks at all like AI, then you're banned. Like your value is to like I'm gonna use AI is not a plan. Or I used AI and I trust the output. Like that's not a plan.
Yeah, the llama, not llama, like Kimi person.
I know, right? And like I don't want to like be harsh, but I also like I'm really attuned to this time wasting, right? I feel like what's gonna happen. My article did pretty well. I feel like what's gonna happen is there's going to be a huge influx of just stuff. And the top performers are going to be able to self-regulate pretty well, but the bottom performers aren't. So even though AI might help the top performers a few percent, the net impact of AI and agents is going to be massively negative because the people at the bottom don't self-regulate. The people at the bottom will flood everything with crap. And yeah, so very important that we stay diligent. Against that, I think we've been doing an okay job, but one whiff of AI equals permaban. Do not use it. That said, I mean, like, okay, I shouldn't say do not use it, right? Like, this is the exact problem, right? You know, this is then you get into like the Dunning-Kruger effect, right? I say like, well, if you're a high performer and you're carefully calibrated and know how to use AI, by all means, use AI. I'm not saying you patch
Yeah,
it.
but those people will probably start from there already. So
Yeah, I think that if I was running a large tech company right now, I would get AI out of there as fast as I possibly could.
I can't believe Bun merged that migration.
I know, I know. Like, I mean, you know, look, never interrupt your enemy when they're making a mistake. It's kind of funny to see the AI psychosis inside Anthropic, and then that gives us a feeling of what to expect from the new model.
yeah,
Uh, I don't know. Like, part of it's just sad to see, but part of it's like, yes, this is what happens when you're in a cult and you really just believe your own hype. Oh, we don't read the code; we just ship it, man.
No, I read probably like a few thousand lines of that font change because it was fun to read.
It's awful. They have a whole breakdown of like how they're now going through and removing all the unsafe blocks, right? Like, and this exactly gets to the problem. Like, so there's a test suite, and they're like, well, the rewrite passes the test suite. I would agree with this logic if the AI couldn't read the test suite while it was doing the refactor. Right? If they had the test suite as like a holdout set and they did the whole refactor and then the test suite passed, I might have some faith in it. But as far as I can tell, they didn't do anything like that. They let the AI just read the tests.
Yeah, we'll see. Yeah,
Right? And you could imagine humans doing the rewrite in the other way. You could imagine like a complete holdout test suite. And yeah, and passing, but I just cannot possibly imagine that working with AI today. So, yep. The policy is no AI. The only way to state it.
I don't know. That feels like the same as the policy is don't be stupid.
Mm, no, because people don't know if they're being stupid. People know if they're using AI.
You also don't know if they are using AI correctly,
Oh
unless
no,
they
but
are.
there's no correctly. That's what I mean. Like the policy is no AI.
Yeah.
This is what's it.
Okay.
No AI.
No way.
Interesting.
I
I
saw
mean,
that you close bunch of issue, so we are going to only officially support our doc.
Yeah, that's another one. I mean, some of those issues, the doc. So those issues probably fall into three categories. There's some that are the doc, there's some that are the GPU choice, and there's some that are bugs in our code. The problem is that's way too hard to disambiguate. So I think our official policy is that we only support our doc. That said, if like someone wants to maintain a page, talk about what other docs are supported, uh, by all means, do it. But yeah, I think our policy is that we close all issues
Do
that
we have a
don't.
similar policies for the GPUs that we support?
Yeah, I mean, we should. We should. So I think for GPUs, we should probably put a. I mean, basically, like anything that's RDNA 3 and up, and anything that's Ampere and up, we should support.
We could probably just add like a docs page.
Yeah, but then we have to also then disambiguate the doc. We haven't shipped our doc yet.
Sorry, like documentation.
No, I totally understand. Yeah, we should add a docs page that says that. What we should do is actually right now we should just we have a doc we support, the ADT UG3
Yeah.
doc. Yeah. Actually, we don't even test that doc anymore. We just test our doc. So never mind. We don't support the doc.
Yeah.
Yeah. Okay. We got to ship our doc soon.
That's good enough. Any other high level stuff?
No, we got that.
Okay. Let's move on. Next is MLPerf and Llama.
So I did a HP model parallel run last week. It's pretty slow. It
Yeah.
took 25 hours. I don't know if
I
that's
wouldn't
just 'cause the shapes are bad.
I wouldn't
Like
worry
it's
too
just
much.
really small shapes.
I wouldn't worry too much about it being slow. I think we just got to get 4 or 5B training.
Yeah,
Try
and then
same thing for the
um, yeah, I will start trying for 70B.
Oh, that's a good point. We should do 70B first. I mean, that
Yeah.
should just work, right?
Yeah, that should just work. With the two peers I have, I merged one. There's another one that does a gather if you go to single device and copy multi. And that fixes memory for 405B.
How did you find stuff like that?
Like this
Yeah, the gather memory one.
AI.
Yay!
Okay, no. So how did you do that? What's your workflow look like?
How did I do this? I told Claude that there was a memory issue.
Okay.
And then I
And-
looked in my Git history and realized that I had made a change before I fixed this, and I just never merged it.
Okay. So you fixed this before. How did you find this issue first?
I don't remember.
Oh, okay. Yeah, that doesn't count, right? It's like, yes, you are good, but I'm trying to see if I can replicate that in some other place.
It's interesting. I read a thing where AI set the record on one of those GPT speedrun things. And the way that it did it was it went through all the PRs and just like cherry picked from like 8 of them.
Yeah, I mean that's a legit strategy when you do research.
Oh, totally. Yeah, AI is very good at that.
I don't know. I still find it's pretty bad, like looking through big logs. I don't know. I tried to get it to write release notes, and it's kind of bad at this.
Oh yeah, no, tasteful. Anything that involves taste, it's very bad at. But if you wanted to
Like,
find
it
a
kept
needle in
messing up
haystack,
the new dev syntax. It was just bad.
Okay, so we should be able to have SubDB working.
Yeah. So the limiting thing on 405B now is CPU memory. We're at 6 terabytes of CPU memory used. I think stochastic rounding should cut that a lot, because right now it's still master weights. So we're still storing FE32 copy of weights on CPU. And a bulk of the CPU memory is going there.
Okay.
And then ML perf stuff. I still have to do the reviews. They were a bit behind because they had to remake tracking issues for stuff after stuff got shuffled around.
Mhm. Okay. I think just the review shouldn't take too long, and
Yeah.
you are
I mean, I think they just use the standard reference implementation, so it should be fine.
just see if there's anything that we might be interested in since they use similar machines. Otherwise, should be straightforward. I also don't expect other people to like really care about our things. So
Yeah.
by the way, how are we getting the line counts for the releases? I felt like this has come up before, but I
is
see
it
there.
now again?
I mean, where did you get that number?
Oh, if you go to line crisis, the bot runs sc.py on each commit, and then it updates the description in
Okay,
line crisis.
When I run sc.py locally, I get 24,000.
did you include a JavaScript?
Yes.
Interesting.
Because
Why would we not include
there's 1,000 lines from this.
I know.
Okay. Anyway, you might want to fix that. Anything else for Llama?
No, should be all.
Speaking of this, next is this.
Yeah, so I've been working on getting the custom C kernels in Llama into UOps and also making Llama go under 2 hours. We had 6 custom kernels last week. 2 of them are now in master in UOps without any regressions. And I have 1 more coming up that actually is beating C in speed. So that should be done soon. I found like a lot of places where we hit decompositions instead of using the actual assembly instructions that are fast on AMD. So I think that's worthwhile. It's just cleaning up C style and adding those operations. Like for example, we don't use max at all in our.
Max?
We don't use max. You mean we're using like the where construction?
Yeah, we're using the condition. It ends up lowering to CND mask in LLVM, and it's very slow. Like that mask change alone is 10% speed difference.
Interesting. Where are these? Okay, they're in extra llama kernels.
Yes, they're in extra llama kernels.
Let's see what the overall UOP kernels look like. Why are my colors weird? Who broke my colors in my editor? No idea. Cool. Okay, so and yeah, there's no regressions on these speed wise. Are you using Beam to search?
For one
Or
of them,
no?
yes. For
Okay.
the other one, I tried Beam. It's slow, and I really tried to like make it work with off-tops.
Yeah.
It's like the difference is 3 hours and 20 minutes run versus 2 hour and 50 minutes run. So I then merged the one that's what's simpler and then use Beam.
I see. Okay, I see. So here you're using like I'm looking at your quantized FP8 delayed. I see you using like unroll specifically.
Yes, and obsto apply is an empty top of them, just disabling that.
Yeah. I mean the question is like how are you finding the syntax, right? Like because the goal of this project isn't just to port these kernels. The goal of these projects is to make syntactical improvements to the UIs.
Yeah, I had one syntax improvement merge so far. It was gated LDS loads. So before, if you had gated LDS load stores, you couldn't use the get item syntax. You would have to use like index pointer true, because the gates wouldn't flow in the devectorizer. I merged something to fix that. But other than that, it was pretty easy to work with the syntax. Even the LLMs just did it. GPT-5 pretty much like can do it if I push it hard enough.
Yeah, I
I
mean
have to tell it to make it simple.
these look like readable. I mean, I don't totally like why. What is this while step?
I mean, you could write it in another way too, but it's basically a Python unroll of the UOPs, right?
Interesting.
Yeah.
Um.
I find it pretty clean in general.
Yeah, no, I mean, I think this is a good project. Yeah, let's keep pushing for 2 hours. The other thing I want you to look at is, so I deleted vconst last week.
Mhm.
And one of the annoying things about this, so now it's just stack and comp. It's a great cleanup. There's no reason, Kenny suggested it, there's no reason that we should have a separate op vconst. It's basically duplicated logic with stack const everywhere. But now the viz looks bad for movement ops because the movement ops have stacks and consts on them. I want you to fix viz so that those stacks and consts go away, but only on a movement op. Right? Like I don't want all stacked consts to go away. I only want stacked consts that feed into a movement op to go away. And like this is kind of hard to do with the current way that we do filtering. Also, client-side filtering is always better than server-side filtering for this kind of stuff because like it's nice to have like the toggles to to hide. Like right now, we should basically move all the op hiding logic out of the server and into the client.
Mhm.
But yeah, if you could take a look at what movement ops have become and kind of clean that up.
Sure.
Yeah, just so we don't see like stacks and consts pointing to every like reshape and expand and stuff.
Maybe you can put an example comment in the viz channel later.
Yeah, sure.
Okay.
Yeah, look into that. Agreed that client side is better.
Anything else? For viz?
Anything else? Yeah, forgot.
Has Tiny now import CI? Who did this?
I did.
No!
It needs Python path now, and I'm sad too.
No, that's gotta go. Why, what broke?
It previously imported CI, I just imported it from.
Okay, let's discuss CI flags specifically later.
Okay.
Are you good with this?
I'll just mention, I'll share the MLPerf in the MLPerf channel, the breakdown of Llama.
Okay.
Currently, this is the breakdown. I've been working very hard on getting a faster gem. AMD's ones are as slow, even slower than what we have. And our gems are only getting like 60% max, 60-70%. So that would be.
I mean, we know that 2 hours is possible, right? Like we have an existence proof. So I'd be interested in just figuring out what gem they used. If our gem is the same speed as theirs, I wouldn't keep pushing on that. If our gem is slower than that, we should figure out why.
Yeah.
Saying that it's 60-70% max, like, I mean, sure, theoretical, right? But just the way that stuff works, it may be very, very hard to get higher. Like, if there's no existence proof that higher exists, that's probably not where we should be focused. We should be focused on whatever Andy actually did, because we know that's possible, and we can just copy it.
I might have to go to
But-
assembly for that, but yeah.
Yeah. I mean, we should flag the kernels that are in assembly and be like, well, this one's going to require assembly, and like, we'll get there.
Ever try to run their thing?
Not their whole MLPerf, but I have their repo cloned and built their
Yeah,
kernels.
I think a natural step after having breakdown like this is to see like, are we like fundamentally doing something wrong? It's similar to a copy thing. Something probably shouldn't exist at all.
It's probable. I mean, like, there's a clear path to getting to 2 hours. Like, we need to get some of these stuff out of the auto-generated and into custom kernels. Some of them are just bad kernels. But the gem and flash extension specifically, I think I can pull from assembly at the MLPerf submission from AMD used as well. Then we'll get to 2 hours.
Sounds good. Okay, next, moving on to HCQ2.
So I've been working on multi for HCQ2 this week. So so currently the whole schedule does not depend on the device count at all, but the problem arises later since the addresses of the multi-buffers of each part are different now. And we can improve this for AM, but not for KVD, like because KVD uses unified memory space. So I mean, basically they.
I'm not following this. Sorry.
So
what's the problem? What doesn't work?
So I mean, in the common buffers, we have some addresses, like to the kernel arguments, to the buffers, and that things. And the idea that on different devices, this address can be different. And my idea is that we can completely share like the same common buffer between devices.
Mhm.
But since addresses are different, like, I mean, we can patch this, like in C.
How I would do this is by putting all the addresses in a tensor, like in a bunch of stacked consts, and then using an index based on the device count.
Yeah, I do exactly that right now.
Yeah.
But actually I thought that in the future for AM, I mean, we can just like for the multi-buffer for all these parts, they can have the same virtual address.
Yeah, no, I mean that's definitely an optimization, but I don't think we can get out of supporting the things having different addresses. I mean, again, also for them to have the same virtual address would require the MMU to be on.
Yeah.
So like, yeah, I mean, I think what we should do, I think the way to think about this is like, we have this kind of set of UOPs that can be quote unquote compiled by the graph rewrite engine. And that will include things like indexing into a stack. So when it's actually compiled, when it's actually like copied to the device, like the command buffer exists in some abstract UOP form, then some graph rewrite comes in that substitutes the variable device num for the actual concrete device num, runs some stuff on it, and then creates the command buffer that's specific to that device. And you could imagine it also, like in order to deal with this, like O of 1, O of n problem. So if you truly have a completely different address on each device, it's going to be O of n. But there's another way to get it to be O of 1 that still doesn't need an MMU. Sure, you could use the MMU and you could map them all to the same virtual address, but you could also have just some mathematical function that computes the address, right? Like say all the GPUs are just at like, 1 followed by 8 zeros, 2 followed by 8 zeros, 3 followed by 8 zeros, right? You could imagine the device num is just a variable and you could like multiply it. And, yeah. That's still O of 1.
Yeah, I mean, that's possible, but yeah, okay.
Well, I mean, I think we
So
want
yeah,
to. Yeah, it's a question if we want to do physical or virtual addresses. It's kind of up to you for whatever like is easier.
yeah, I see. I know. So yeah, the current implementation is the table. Yeah.
By the table, you mean like stack const?
Yeah. So basically, that's so in simple words, how this works right now. When I create, like for example, I need a timeline address, and I just have the not realized like buffer, which has like several devices, like a tuple of devices. And I just have after that a rule which will like bufferize this like placeholder buffer with mstack and the real buffers behind mstack. And
Did I expect HCQ2 to work? I just ran HCQ2 equals 1 and it's hanging. Oh, it eventually worked.
I'm not sure I merged all the changes which are outside of HCQ2.
So it's just like yeah. Can I see these? Can I see these command buffers in Viz?
Yeah.
How do I do that?
Wait a second.
It eventually ran. It just felt like it had to like import something. It took a long time. So I don't know if it really did anything.
Okay, I'll fix that. But so yeah, so for multi it doesn't work in the master right now because of the profiling issues. But
I don't even mean for multi. I'm trying. I got my one local AMD GPU. Oh, I guess it's not using AM. It's using AMD GPU. That work? And
I mean, these I posted in HCQ, so this command works for me.
This command work. Yeah, that's pretty much what I ran. There. I'm on master. I mean, it works. Not that it doesn't work. I just like, so where do I look to actually see like the command buffer? I see qualify, I see schedule, I see one kernel compilation.
Yeah, so these there should be like HCQ schedule in these.
Oh yeah, I don't see that. Latest master. It's the HCQ schedule in Vic. Oh, let me just say dev equals AMD just in case it's actually okay. This is kind of an annoying bug, like in general, that has tripped me up a whole bunch of times. So it's not a bug in HCQ. Well, I mean it is, but I didn't know that it wasn't actually running on the AMD device. It was running on some other device. So I just see AMD 0 does not exist. My strict have a laptop. If I do HCQ2 equals 0, it doesn't do this.
Yeah, it only works for AM, I believe.
Oh, it only works for AM. Okay. Let me see. What's the issue with AMD? Oh yeah, okay. Now I see. I ran it on a Tinybox. Now I see HEQ schedule. Cool. So this HEQ schedule is running for each kernel.
Yeah.
Why? Why isn't it one graph rewrite for all of them? Oh, maybe it's actually submitting like that. Like, I don't know. Like, is it one HEQ schedule per realize, or is it multiple HEQ schedules per realize?
No, actually, like in runtime currently there is one HCQ. I mean, so in runtime it just runs, compiles these. Like this schedule is per kernel. In graph it just takes all the kernels and have one schedule.
I see. Yeah, I mean, we probably shouldn't have that, right? It should probably be one. Like, I'll post what I'm seeing right now, and I'm seeing, I think, way too many schedules. It's just going to be really slow. Like, I don't know how many times this thing is actually calling realize, but for each call to realize, basically, there should only be one HCQ schedule.
Yeah, I see. Okay, but I mean, I'll think about that. But basically, we can have like different. Like in runtime, we can have like interleaved like AMD kernels and CPU kernels. And
Yeah, no, that's fine. Here, I mean, I should just run something. Let me run test mnist instead of something's really slow doing this though. Test mnist took 6 seconds. Yeah, I mean, there's tons and tons of HCQ schedule being submitted here. This is for test mnist. There's just no way we can afford to do all these graph rewrites. This has to be kind of like one thing. don't see any submits later on either. I only see some submits at the top. But yeah, you see what I'm saying? Like, why do I see all these HCQ schedules?
Yeah, so basically, I just take one kernel and just run the schedule and build the like the csubmit program for it. But
Yeah, I don't think it should be this, right? Like, I think it should be for one graph, you build the program. Like, we have the normal schedule. There shouldn't be more. I mean, maybe there could be like a few more HCQ schedules if you're dealing with the fact that it has to go to like different devices. Like, yeah, there can be like one main schedule and there can be like then one HCQ schedule per device. But there can't be one HCQ schedule per kernel.
yeah. Okay, yeah. I'll think about that, but yeah.
I mean, think about basically like there should be the same number of HCQ schedules as there are like doorbell rings. Right? Like when you're about to ring the doorbell, that's when everything should be scheduled, when the command buffer should be built.
So that exactly that. I mean, because we just like execute kernel just one by one. I mean, that's runtime, they're not graphed.
Yeah, okay. We have to just stop doing that. Like, it should just automatically become graphed.
Yeah.
Is there any downside to that?
I think no.
I see why this is happening, right? Like I see like what invariant you preserved here. Like historically we've been submitting the kernels to the GPU one at a time if they're not in a graph. But yeah, I mean this kind of stuff's absurdly slow, right? Like one schedule should be one graph. There should be no more distinction between the two. Right? Even if you want to do something like not put it all in a single command buffer, even if it's like 3 command buffers that you want to split just so you could like submit small ones early, that should still basically be one graph rewrite to compile them all to command buffers.
Yeah, but yeah, okay. I mean, that's not implemented, but basically that's the feature to just graph, to just use graphs in this schedule.
Yeah, but I'm saying like go even further with this. The other features should kind of like be gone. There shouldn't be really a way to do it like without graphs.
Yeah.
Yeah, it's kind of like, yeah, sure. You can always just say that, okay, what I'm basically doing is submitting 30 graphs of size 1. And of course, that should always work. But like, there should basically no longer be a distinction between graphed and ungraphed. There should just be like, I have 30 kernels to submit. Of course, I'm going to submit them in a batch. Unless I like set some flag to not do that.
Okay, I'll test that. Basically,
Well,
maybe the
don't-
current downs. Yeah.
There's a lot of copies too. All right, go ahead. I didn't cut you off. Showing the current downside?
No, it actually takes some time for the graph to be built, but if it's cached, I think it might be fine. Yeah, I'll do that.
Yeah, but we should focus on, it's just important that it's O of 1 graph rewrites for a schedule, not for a kernel. Like the number of calls you make to the graph rewrite function should not grow with the number of kernels in the graph.
Yeah. I mean, they're kind of the same because I mean, the more kernels you have, the more patches you have, the more overwrites you do.
But that's different. That's the number of UOPs, not the number of rewrites. Right? The number of rule triggers can be O of n, but the number of calls to the function graph underscore rewrite needs to be O of 1.
Oh, okay.
You see the distinction?
Yeah.
Yeah, of course, you're going to need patches that are O of n. That's really fine, but.
Anything else?
No.
Okay, let's move on. Next is my stuff. So made a bunch of changes to tensor.py specifically to requires grad. So now requires grad is removed. Under the hood, everything code can have a grad. It really depends on if you use such grade or not. It's like lazy. And replacement in terms of optimizer it's a different field called is underscore peron. So that's just a flag for the optimizer to know if it should include things as a peron.
I think that's a super reasonable way to do it.
Yeah, so I think that is done. That's why I closed the tip for that. Then the next big thing I was working on and still work on is device list const. So the idea is const is always in line, so it should not have a device. For now, the const can have a unique source and a device source. So the eventual goal is to like remove those, and const should always just be the same. Yeah, a few things left done. So for now, if you construct a tensor const, it doesn't have a device in it, and I also remove tensor dot from underscore uop. That was a specific function that just doesn't make sense. It was there because the symbolic shape of const didn't have a device, but const was requiring a device, something like that. So that is gone. The near-term API change would be if you call test.full, test.ones, test.zeros, we would just add a clone at the end to those functions, so you get a buffer instead of a const. We discussed about this. I think this pretty much fall into users' expectation when they write this, especially with a weight. Then if you want a fusible const, like how you do in Winograd, or in other cases, like you want an inlineable const, then you just call that const, and you will get that. And you might need to. I also added a flag called buffer to the full. So if you call buffer equals to false, then it also does the const, then reshape, then expand for you. So you got a fusible version of that. The current bottleneck is on invalids and anonymous buffer and function.py, because there are certain assumptions about that mechanism that rely on the unique const. So I don't quite sure is there like any ongoing plan to that?
I don't think anonymous buffers actually work. I think if there's any stuff for anonymous buffers, we could rip it out. So the real answer to anonymous buffers isn't some like carefully constructed store after thing with an anonymous buffer. Like we can just delete all that. That's just wrong. That should just be replaced by load. Like load is an anonymous buffer. But for now, I don't think we use that logic in anything, and we can just rip it out.
No, we use that logic for everything.
What do you mean for what?
So you can see my invalids is empty PR. We use that to build in function.py.
Valid is empty.
Yeah, basically all the where we call invalids to do stuff.
Yeah.
So I just replace I with empty and make it work.
That seems totally fine.
Yeah, because we were discussing about this, and I remember at some point you say empty should be invalids.
Yeah, it should be invalid.
Yeah, so if that looks good to you, I'm going to clean those up and probably delete invalids unless we still want that mechanism somewhere.
We can't get rid of invalid, I don't think.
No,
Oh,
now it's just empty.
oh, like, yeah, that's fine.
Okay.
Yeah, that's fine.
Okay. Yeah. I was thinking about this.
The other thing to move to mixins
Mhm.
is gradient. We have a mixin for gradient that also moves gradient.py there.
Sure.
Notably not backward. Backward stays in tensor.
Yeah,
But
yeah.
gradient should be a UOP friendly method.
You want gradient in mixing or gradient in gradient.py?
I want gradient.py. I want all that logic to go to mixin. And yeah.
Yeah,
Right, like,
it should just work, right? It's just given a function and take the gradients of or
yeah. It's just calling tensor in a few places, creating that tensor with the 1.0, like, that should all just work in the UOPs.
Okay, sounds good. Yeah, I think this should be the last. I mean, the invalids was the last place that we have const. We certainly use unique const. I think that's also the only place that const as a buffer. Sorry, const as a device. So once we remove all those, should be able to keep just const of const.
Great. Super happy for that to be deleted.
I think it's pretty nice.
Yeah.
I also, you don't expect to update like function.py anytime soon, right? There are a few commented outlines that I don't know if you want to have it or not have it.
Yeah, I mean, function.py exists in this liminal space between the old JIT and the new JIT.
Okay.
The lines that like add contiguous and assign the output. I don't exactly know how to resolve all of that yet.
So then my take is I will try my best to simplify those, and if I find something up that doesn't break anything and I think it's cleaner, I will just merge it. Is that fine?
Yeah, I think that's right. I think that there's a I think that preserving the kind of logic
Because
of function, right?
yeah, you also see some like allow device equals to something bug. There's a flag for that.
Yeah, so I mean what's happening there is these things are not actually pure and they're opening the device for various reasons.
No, but it doesn't open any device now.
Okay, then maybe you can remove that. Maybe it's fixed.
Yeah, I mean it was some const.
That's great. Great. And I'd love to delete that device and function bug crap.
Okay. Then I will clean up that as part of this refactor.
Yeah, but the basic thing, I mean, we have a unclear distinction right now between function and call and what it means to be stateless and stateful. I think this will help like once we finally understand like load a bit more, because you need anonymous stores. You can have anonymous stores in a function. You just can't have named stores in a function because a named store has side effects.
Yeah, and I think that's
Where the
reasonable.
load doesn't have side effects. And like there's a really key distinction there. So like when we start to tighten like that idea up, but the basic invariant is that function has no side effects and call has side effects. Function allows you to return stuff, call does not. And then it's also like the decorator is called function, which makes it a little bit confusing. But like we need something like this. Like I tried really hard to do without this, but you can't because it's a different complexity order. Right? The ability to have hierarchy. Like there's a reason that every programming language supports something that looks like functions because it gives you hierarchy, and this hierarchy turns O of n into log n.
Okay. Anyway, I think I know what to do next, and we can move on to the next point. You address like assembly.
Yeah, so I merged x86 assembly. I think that there's a bunch of things that aren't great. There's a bunch of fragile things in that code. But it's not exactly the fault of the code, and it has more to do with that D-type vec is a problem. These constructions where, like in assembly, very often you don't say load 2 floats, you say load 64 bits. So there's like this distinction that's not so clear in assembly. I think a lot of the matching rules are very verbose. But again, some of this is like I have to look and see a better way to write it. But I think the big victory with getting assembly merged is that it's very clear where two things live. One is the register allocator and one is instruction selection. And instruction selection and register allocators are not, they're not abstract concepts. They're not like there's something that you need to do and you need to think about. And I think it's important that we think about them as soon as possible. So right now we have something called the memory planner. That's basically a register allocator. We have decompositions, which are basically a form of instruction selection. So yeah, I mean, we already have things that look like this, but it's important to make these things explicit, to get us out of this. Oh, but then you just dump it into LLVM mindset, right? Because like a lot of what Tinygrad is doing can also be done by LLVM. And you can take LLVM and like any of our graph rewrite passes, you can have it do a lot or you can have it do a little. So it's nice to actually have an end-to-end path that has 0 LLVM and continuing to work on that and clean that up, I think is important. Yeah, that's assembly. Merged, it works. Dev equals CPU colon x86. And then for D-type vec, it's just removing that forces a lot of questions. I'm working now on, so D-type vec is used in a few places that like aren't where you think it's used. There's the obvious place where it's used for like arithmetic, and this is equivalent to shape. If I have like a D-type vec 4 plus D-type vec 4, I get a D-type vec 4 out. That is equivalent to a shape of 4, shape of 4, shape of 4 out. There's two places where it's being used that don't match that idea. One is in images, and that one's fixed. So we used to use 2D indexing in images with a D-type vec 2. This is fixed to actually be proper two-dimensional indexing. And then the other one that I'm working on now is the one where we do like a load of 4 contiguous elements, right? So we can do like a load 4 in a GPU is like a real instruction. This can't exactly be an index because the index would require you to specify 4 addresses. And that's, of course, not what a load 4 on the GPU actually does. The load 4 on the GPU requires you to have 1 address, and then it loads 4 from it. So historically, we've done that with D-type vec. We've had an index, which is a pointer D-type, and then we dereference that, and we get the underlying shape of the D-type, which is just insane. And like the fact that like you can put pointer before the vec and pointer after the vec, and it means something different. I mean, like, yes, it's like this in C as well, but that doesn't really make it okay. So my plan now is to move that to buffer view. Because buffer view is that exact thing that we're talking about. Right? Buffer view is basically saying I have an offset into a buffer, and I'm taking a certain number of elements from that offset, and those elements must be contiguous. So I'll be able to use a buffer view And then by putting a load on that buffer view, I can load 4 contiguous elements in the same way a load 4 does. And this also allows you to load 4 without. So one of the problems with using index, you're like, okay, I could just use index. It could be like a 2-dimensional index and I'll reshape it first. But what if you want to load 4 from index 7? Right? There's no real way to do that with index. I mean, you could specify 7, 8, 9, 10. But now you have this like const and you got to check it. And it's really complex. It's much easier to just say, okay, that's a buffer view with size 4, offset 7, load, done. It'll kind of be my week this week. One more long slog to the removal of D-type vec. But it's good. It clarifies some things. And then you also get into like, okay, D-type vec, buffer view, and bitcast. Are those the same thing? Are those different things? That's a
Do you
project.
want to do the shape changing bitcast?
Okay, so bitcast means 2 things. There's shape changing bitcast should not exist as an op. Shape changing bitcast is buffer view. If you want to change a shape, the only way to do it is with buffer view. The question is, why does a buffer view only have to live on a buffer? And that gets, yeah. But the idea of shape changing bitcast definitely should not exist. In fact, there's even a question, should bitcast exist at all? And I'm going to look into how it's used. But like buffer view also lets you change a D-type. So.
I mean, that would be nice. One of the things that's left on tensor.by is all the bitcast on disk.
Yeah, I'll think about it on disk. I'll think about I'll talk to LLMs a bit. I'll like understand how like C++ dealt with this. I'm not that familiar with like the latest. Like if you ask me what reinterpret cast meant, I'd fail that class. So yeah, but I'm gonna look into how other languages have like dealt with this.
Sounds good.
I know how C deals with it, and like the way that you do a bitcast in C is actually by assigning something to a buffer, dereffing the buffer, and then referencing the buffer and then dereffing the buffer as a different type. So yeah,
Is that an awful thing with unions?
yeah. You can also do it with unions, but that doesn't actually always work.
Okay.
The union doesn't actually guarantee that they're, but yeah, whatever.
Anyway, looking forward to that.
Hack union.
Yeah, that's
Yeah.
yeah,
Yeah, that's
let's
my
move on to CI and test.
Yeah. Yeah. So, I mean, the reason that there was that stupid thing in test tiny is it did previously depend on the get MCI, but I removed all of get MCI from for tinygrad, and I wanted to delete it from tinygrad helpers because then there's less temptation to add it back somewhere.
I want to remove it from all the tests. So any test that doesn't pass in CI should just be deleted.
Yeah. Yeah. So that's a good solution to make that one not require Python path. Yeah, the other thing I did was, like at least within the core tinygrad, was removed is dtype supported. So instead, now you have your renderer, and then you can call dot supported dtypes on it, and then it gives you a set of the supported dtypes. And so that's nice because that was that could is dtype supported was pretty hacky and unreliable. So hopefully it's a lot more reliable now. And yeah, so then I also started cleaning up some of the tests. So for instance, like a lot of test randomness, I might move that into unit. And so not all of it, but most of it is moved into unit now. So that should make it a little faster. And there's also just some like general like looking at some of the slow tests and trying to figure out whether or not they were really needed or not. But yeah, that's still an ongoing project to figure out whether or not tests are necessary or not, and just clean them up if they're not, if we don't really need them, or if they're testing stuff that's silly to test. Yeah, I think that's most of it. I have some ideas about how to do fuzzing, but I feel like before I add more tests, maybe I should try and clean up the old ones.
Yeah, let's definitely do that. Yeah, 2 things. I think that makes a lot of sense to put on the renderer. You have is op supported, is dtype supported.
There's no is-op supported, but there probably should be.
There is an is op supported. We just call it we look in the op stick.
Yeah.
But yes, we should have a method on renderer That should the idea of a renderer saying I support these E-types, I support these ops is a universal. That's going to be in the end system. You have
Yeah.
this idea, right? Let's just-
There's some question about, and I think this is like an OpenCL idea, but I bet it exists for other renderers. Is like, okay, so you can support a D type, but you can only support loads and stores with a D type, and you can't support math on the D type.
Yeah.
So
We can have that distinction. That's fine.
yeah, okay.
But yeah, the point is that these should be renderer methods, not global methods that check the renderer string name.
Yeah,
Yes.
yeah, for sure.
Yeah, no, I also want you to unify test. I mean, I know that I broke them apart, and I think that it was like worth thinking about, but we should think about how to reunify test unit and test null.
Okay.
So the distinction right now is that test nulls don't require any device, and unit requires some device. But you know, null is a subset of some device. I think that we should basically just split tests into two categories, which are tests that we want to test on every backend, and then tests that we can test on one backend and be confident that they're right across every.
Yeah, I did this for the randomness stuff, where it's like, okay, like as long as they all generally support randomness, then all of the behaviors of like saying, oh well, random needs to be normal is probably preserved, assuming randomness is preserved.
Yeah, and then I think we do have this like third kind of tests as well, which are they're not they're still unit tests. They're definitely all a subset of unit tests, but they're kind of like application tests. Kind of like the whole AMD emulator. Right? It's kind of a tinygrad application. LLM is kind of a tinygrad application, right?
Yeah.
So like that's we have like unit tests, which test correctness of tinygrad. We have backend tests, which test the correctness of renderers, and then we have application tests, which like test could kind of almost exist outside tinygrad. Not outside tinygrad, but like they're not tinygrad tests. And every time that we get a failure, only in an application test, if the bug is in tinygrad, that's bad. If the bug is in that application, it's fine.
Yeah, for sure. Yeah, that makes sense. Yeah, and that applies to like the Onyx front end as well. Like,
exactly. Onyx is an application test.
Yeah.
Not a
Right,
and then we really treat that as a very bad thing.
Yeah.
An application test failed because of a bug in tinygrad, and then our invariance wrong.
Yeah, for sure.
Yeah.
Yeah, that means the testing as well. That's not wrong with the testing. But yeah, I think that's kind of it.
Yeah, it's about time. Let's comma happiness.
Yeah.
We have a bug with image and render vibe. Everyone's complaining that one of the model that he added a bunch of layers and it's wrong. I just put a very quick hack for it, but I think something is wrong there.
I saw your fix and I didn't understand it. I don't even understand how image can break rangeify.
So the way image creates range, I think in that context, there was an assumption that every range are unique, and that's not true.
Image creates range?
So basically in that function, there's a key collision. And how image creates that and why that's the case, I'm not sure. But that was the cause of the issue.
Thank you for fixing it. Yeah,
if you disable like you up cache, then that's also fixed.
Even worse.
Yeah, so
Oh, I see. Yeah, image hack for
yeah. So
I was sick and I tried to read this and I couldn't.
No, I mean
I still can't read this.
Yeah, I mean
is this happening because there's two reduces ending the same?
Yes.
Yeah, that shouldn't be possible.
No, that's only possible the way we write flow 16 thingy.
I see. Okay.
So that's kind of out of spec, but kind of it's broken now. So
yeah.
I mean, not clear if we want to do anything about this now, but
I don't know. That if clause looks like some AI.
But yeah, I just saw this for that.
Just nest two any's. Nest two any's. Include a for and an if. Why not?
Yeah, there was a another attempt. Like I try to fix this in the reduce context by including that, but that fails some other thing. So
Yeah.
if they are happy with this.
Yeah. Okay, maybe I can take a quick look today if I just see what it is. Because
Yeah.
every time I've seen this happening where like a range is ended twice by two different reduces, it's usually caused by some like upstream bug.
Yeah.
Yeah.
There's the other thing that Kama's complaining about, which is the JIT like deduplication in image.
Won't fix.
Yeah.
I mean, that's yeah. I think that will fix itself someday once the JIT can basically capture two functions at the same time. But until that can happen, there's not really a fix.
Yeah. Well, the other thing is they could unify their model if they did like a symbolic compilation of the warp. But I think that was slow. So
Well, that's a different issue. But no, if they're asking for like a quick hack to fix that, I don't know. Can I use like gzip on the pickle?
that's what I said.
Yeah, does
But
that fix it? Was there a RAM issue? Is there a size issue?
I think I told them to run gzip on it, and they said that it worked for one thing, but it didn't work for the other one. And so I don't know. But I think gzip accepts an argument that like how long to think about what compress.
Yeah, there's a context length. I don't know if I find the context, but anyway, I don't know. That one I don't have fixed, but there's a real bug. I can think about that one if comma is really blocked on that, but really they should think about how to hold it differently.
But yeah.
We have anything else? Or what about the Llama 70B fine tuning thing? I'll defer to you if you think that's good. Find a way for
Yeah,
that.
I didn't get to take a look last week. I'll take a look this week.
Okay. Sounds good. And I think we still have some like opening PRs from B1TG for the LLM stuff. So let's try to do something for those.
Hello?
Hi.
I take a look of the Llama shard regression. The branch history account. I found this it was exist since the Rangify defaults. Before that, shard is faster than the no shard.
Okay. Yeah, there's certainly definitely perf regression for sharding. It's nice to address those.
Also, all the commits make the shard slower. But after Rangify, I'm not sure this is relevant.
So I mean, it's not very helpful to look at the commit a year ago and say things were good before that. Probably need to find a way to root cause and fix the issue.
Yeah, this probably has to do with like the interactions between shrink and copy. But yeah, I would just try to find like a minimum repro that did a different thing before that versus now, and then we can look at it.
Okay, I also read some Llama CPP's code, and I found they do the GMV at the int level, not the half offload. I test with some custom kernel and push the Kimi decode speed over 15 token per second. And which is the preferred way to upstream the custom kernel? We need to use uops, not hip code now.
UOPs are preferred if you can write it in UOPs. That's always a lot better than writing it in hip code. But if there's no way to write it in UOPs, then
I mean, speed up need to fuse those kernels. So just need a custom kernel.
I think generally if custom kernel it's the only way you see to do things and it makes a very big difference, then it's probably worth considering. But if you think that's just temporary, then it's not worth considering. This is very hard to say without a change, but UAP is preferred unless there's a strong reason that it cannot be done.
Yeah, the deeper question here, whenever you're thinking of adding a custom kernel, is saying, why can't tinygrad output this kernel? Right, like I wrote the custom kernel for embedded backwards, and the reason tinygrad can't generate that kernel is because of atomics. Right, there's like a clear, oh, well, here's why tinygrad can't do that.
Seems we lack the packed in int.
Well, why?
And we don't generate those on this function. And if we want to do the metrics in the int level, we need those or speed up.
Interesting. Okay, I mean, yeah, if it's a custom kernel, it's a custom kernel, but
At the same time, I can make the tinygrad generate those code and see if it's fast.
yeah, if it already fits into the existing abstractions, that's kind of the question. But I would focus more on the sharded stuff. The sharded stuff's a lot more like fundamental, right? The sharded stuff, like it's fundamentally incorrect to put some layers on each GPU. Right? Like that's just not how we want to do it. We want it sharded. I always like correctness before speed, always.
Okay.
Okay. Cool. I think that's about it for this meeting. Anything else?
Oh, I think we're already over time.
Okay. That's it for today. Thank you, everyone. See you next week. Bye bye.
Bye.